Okay, so last week we learned how to protect our data or database. Today we'll look at stored procedures. Why do we have to have a stored procedure? It's not just part of security. Yes, it's part of security, but it's also a way to speed up performance of a software. When you have the code stored on the database, you have saved the time of um, moving code from server to database and back. Because the code is now resident on the database. That's why it's called stored procedure. You are storing the code, not on PHP, but on MySQL. You store the code where your database is. And then you now use PHP to call the code and it will run. So one advantage of having a stored procedure is that you can reuse the code. So we want to look at two major types of stored procedure: triggers and views. So a trigger is a stored procedure that is automatically executed in response to certain events on a particular table of view. The events that can activate a trigger include insert, update, and delete operations. Triggers can be used for data validation, enforcing business rules, maintaining data integrity, auditing changes to data. So what we call trigger is a kind of a reaction. You are writing a code that tells the database, if there is any change on you, do this. That is what trigger is. You are telling the database, if anything happened to you, do this. If there is a new input, do this. If there is an update, do this. If someone deletes something from here, do this. That's what trigger is. So you use these three statements to set trigger: insert, update, delete. Because these are the actions that affect your database. That someone selects something from your database does not affect it. That's why select statement is not part of this. I don't know the exam you will write. They may ask you the statements that affect trigger or that works with trigger. You should know that when someone selects data from your database, it does not affect that database. Or do you think it does? It does not. The person is just reading information there. But if someone inserts something into that database, it affects it. If someone come and change what is in that database in the name of updating it, it affects it. And if someone deletes what is there, it affects it. So you want to keep track of these actions that affect your database. Anytime there is any of these changes, let there be a reaction from the database. That is what trigger is. Trigger has many applications. So you can use it to do data validation. You can use it to enforce some business rules. We'll see some of these things. Use it to audit changes. So when there is a delete, you can say, okay, anytime someone deletes something from the database, give me a copy of that thing that is deleted. Because trigger can happen before and after. So you can say, after someone deletes something, give me a copy of that thing they deleted. Or before you delete something, give me a notification first. Let me approve it. So from the PHP side, from the public side, they have issued a command to delete something from the database. But that thing will not delete. It will send message to you first as the admin of the database. You look at it. Okay, they want to delete this thing. Who authorized it? You see it. If it is a valid action, you now click OK. It will not go and delete. If it is not a valid action, you can roll it back. So these are some of the things that trigger can do. Trigger can happen before that action takes place. Syntax of SQL trigger. To create a trigger, you use the create trigger statement. The basic syntax is as follows. Create trigger, you give the trigger name, trigger time, trigger event on the table name for each row, trigger body. So what this syntax means is that when you want to write code for trigger, you call the trigger a name, you give it a name. Just like when you are creating a table, you give it a name. You can say this is a registration that data in another table. Is it to make calculation before it will save? Whatever you want it to do, you write it on the trigger body. Before, trigger executes before the event. I've already explained this. So when you issue a command on the database, it will not just go and rush and do it. Maybe you want to submit data. You have filled the form, so you click submit. It will not rush and submit. If you're using trigger, you can stop that operation. You can stop that thing from saving. Let it show you what you want to save. So you read it first. Even if you didn't sanitize the form, you can use trigger to still control your database. Before you submit anything, it will show you first as the admin. You look at it. If you see that it's from the bad boys, you can order it not to stop. But if you look at it that it's clean, you can allow it to go. That is the before trigger. You also have the after trigger, which executes after the event has taken place. There are situations where you want that to happen. Let's say, for instance, you are writing a code for inventory management. As there is a new supply, you may want to increase the quantity of things in the store. Or if there are sales, you want to reduce the quantity in the store. Assuming in the store we are selling laptops, so we have 5 laptops. When they sell 1, how many are supposed to remain in the store? So you can now issue the trigger that anytime there is a request or a report, sales report coming, take the quantity, use it to subtract what is in the store so that we can have balance. So trigger can also do that, and that is an after trigger. So you do it after sales, you do the trigger. Okay, so this ones are self-explanatory. Trigger events, the event that triggers the execution. We have talked about it. There are 3: insert, update, delete. Only these 3 statements out of the 4 statements works with trigger. That's what we call trigger event. Then the table name is what you give it. Each row is a statement that commands each of the rows that is affected by the code. Then the trigger body. I've explained this also. Before trigger. Before trigger executes before an insert, update, or delete operation on a table. It can be used to modify the values of new for insert and update, or old for delete and update. So what do you mean by new or old? When you're writing trigger code, you can also use that keyword, new, old. So when you update a table, let's say that there are 5 items in the store and you sell 2. How many is remaining? 3. Before that 3, the old value there is 5. Now that is remaining 3, the new value is 3. So with the command of new and old, you can actually fetch whatever you want from the table. You can look at the old value, you can look at the new value at any time you want, whether it is before or after. So trigger makes room for, you know what happens in WhatsApp? If you send message now, you can edit that message. I hope we know. Correct. But after some time, you can't edit again. That is trigger. Because that trigger now is referring to old and new. Even though you have already sent the message, you can edit it to new. So that's what trigger does. It allows you for that old and new. Even if an information has been deleted, you can still use it, but for a short period of time. You can still call back what is deleted using the old command. Old will show you what was there before. Even when you have updated something from the database, if you want to see what was there before the update, you call the old command to see it. Why is different from undo is that undo will remove what was inserted. Insert employee, you can call it any name. It can be any name. Then before insert on employees, employee is the name of the table. So the name of your own table is what you put there. Then for each row, begin. If new salary, is less than 0. So new salary is the information they want to install. They want to store in the database. If it is less than 0, then set the new salary to be 0. This dash dash is a comment. We've talked about comment before. That means it will not run. So ensure salary cannot be negative. That's what this code is doing. If someone wants to save salary and that salary is not a number or it is a negative value, then the system should change it to 0 and store it. That is what this instruction is saying. So that even if you insert code where you're supposed to write salary, that code will not run here because it will change it to 0 and store it. So the code said that this trigger ensures that whenever a new row is inserted into the employee table, if the salary is less than 0, it will automatically be set to 0. So let's look at another example of trigger. This one is an update. So they now say create trigger after update salary. So the name of the trigger is after update salary. Are we following? Yes. After update on employees, employee is the name of the table. For each row, begin. If old salary is not new salary, you know what that statement means? If old salary is not new salary, what does it mean? If the salary have changed. Good. That is when this action will take place. That is, someone have come to change his salary. Maybe because you are the new admin, you are the new database admin. Your friend is employed in that company. During salary time, you now add 0 behind his salary. You know what that means? That means if he's being paid 50,000, his salary will not be how much? So if new salary is not old salary, send alarm to the Oga. But the problem with this code is that it is an after command. That means the person must have reached salary and Japan. Must receive his salary and Japan before Oga will know. So that's what I see is wrong with this code. So where do you think we should write this type of code? It should be a before code. Before you make this change, let Oga know first. Okay, so if old salary is not new salary, then insert into salary audit. So what this thing is doing now is saving this data in another table so that when they want to look at actions that are queryable, they will go to that query table and they will see this one, that this salary was changed in so time. So that's what this code is saying. It's telling the database. Remember that this code is not PHP code. It's SQL code. You're going to write it in your SQL server on your machine where your database is. So the execution is fast. The execution is solid. It cannot be interfered by outsiders. That means no SQL injection. Nobody can attack it. It stays there. So there's a table where the audit table where it will now install those actions that are queryable, so that when Oga look at it, he will see them and query them. So it will store the employee ID, the ID of the employee that the salary changed, and the date that it was changed. Yes. Mhm. Yeah, it will not take place. That is, if you remember this code now, this particular code now, did not send alarm for it to be approved. What the code did was to save this action in another table. So in this case, it doesn't need approval before it demands approval. That means maybe a notification code. If you use before, that thing will not submit until the notifier gives approval. But for this one, it will just save the data and allow it to run. For this one, that? Yes, ma'am. Because that's the instruction given is after. To before. It will first of all save that data on the salary audit table before this one will take place. But it does not require approval. That's what I'm saying. For this code, it does not require approval. If you look at this place. This place they say value. I don't know if my mouth is moving. This place now, this then from here to here. Any code you write here is what will execute. And nobody will tell you what the code is. For this guy, he chose to save data in another table. That's what he chose to do. In your own, you can choose to send notification. In your own, you can decide to call up a login form. Let the person log in first. You can decide to do calculation on the salary to determine the amount. If the amount is less than 100,000, allow it, even if it's a small money. But if it's bigger money, no. You are the one that will decide the code you will write here. That's what I'm saying. There is no constant code. But let the code be between them and end if. So let's look at this code on trigger. This is also the trigger code on delete. So he said, create trigger after delete employee, after delete on employees. For each row, begin. Insert deleted employees, the employee ID, the name, and the delete time. Values, old employee.id, old name, and now, end. I want to ask questions. Number one, what is the name of this trigger? You say what? After delete employee. What's the name of the table where the trigger is stored? Okay. So let's look at use cases for triggers. Data validation. Trigger can prevent invalid data entry. Just like what we did when salary is less than 0. We say change it to 0. You can also say don't install, don't insert it. You can issue any command you want. This is programming. Whatever you program is what the system will do for you. So we call it data validation. So you can prevent invalid data entry or modification, such as ensuring the integrity of data with checks before an insert or update. Like if you collect phone number, you can check whether the phone number is 11 digits. If it's not 11 digits, you don't save it. You can, if you are collecting account number, you check that it is 10 digits. If it's not, you don't, because there's something we call data quality. I mentioned in the last class. You can collect data and it doesn't have quality. That means it's not usable. So you have to check that the integrity of that data is valid. So you can use triggers to do that. Another thing you can do with trigger is auditing. You can track changes to the table for accountability and for security purposes. For example, logging who updated what and when. Who is it that authorized this update? When did he update it and what did he update? You can track it by saving something in another table. Whether it is update, whether it is delete, even insert, so that you can track who did what, especially in a multi-user environment. Cascade operations. So trigger can automatically modify related tables when the data is modified. For instance, when a row in the parent table is deleted, a trigger can automatically delete all the corresponding rows in the child table. Another way we can view it is, I use store already. If you are writing inventory code, so when there is an update in the supply, the store value should change. Or when there are cells, the store value should drop. So that is cascaded operation. One action, but multiple effects. Then automatic computation. Triggers can be used to perform automatic computation, like updating the product stock account stock count when a new order is placed. But because trigger is good, you have to be careful how you use it. It has some performance issues. One of them is overhead. Triggers add an extra layer of processing to the database operation, which can result in performance overhead. What we call performance overhead is that if the database is a busy one, a lot of queries are coming in, a lot of insert is happening, a lot of updates is happening, a lot of delete is happening. If you have many triggers, and if some of them are on before operation, that means there'll be a lot of queue of activities. And if the system handling your server doesn't have enough memory, or there is no much bandwidth on your network, the system can freeze. If you continue to put that pressure, it can crash. So you have to limit the number of triggers. Complexity. Why triggers are powerful, they can lead to hidden logic and make debugging difficult if overused or poorly written. This is also another thing to look out for, because trigger can trigger many operations at the same time. Like you can write one trigger and use it to affect too many things. Now, if your code is becoming complex and a lot of things are happening in the database, you may be confused which trigger is causing these things. That is if you remember that it's trigger that is doing it. Because you may think that your database has something has gone wrong. You can even blame the PHP guys. That what nonsense are these guys even doing on my database? You will know that the query, the complexity of your trigger is causing it. Mother, you want to say something? Okay. Yes. Mm-hmm. Mm-hmm. Um, what is that trigger? You can also use trigger. You can also use trigger depending on what you want. But that one is view. Yes, that one is called view. It's not trigger. But what you can use trigger to do, maybe you want to track how many scans did they have they done in a day. So you can put a trigger. Anytime there is a scan, trigger will store what was scanned on a different table for you without the user knowing. Because the trigger is running behind the scene. But it's not trigger that is doing the scanning. That one is view. Remember, trigger does not have select. Are you following? But when you scan and see something, that one is select. Trigger doesn't do select. Conclusion. MySQL triggers are an essential feature for automating tasks and ensuring data integrity in databases. They can enforce business logic, improve efficiency, and provide a layer of data protection and auditing. However, they should be used carefully, considering performance and maintainability. So you don't say because trigger is very powerful, you now go and use it for every code. Allow PH people to do their job. So, but if you have your audit table somewhere that tells you who logged in when, who did what when, when Oga say you say, I have something to say. Oga will say, what is it? He said, come and see who did it. And it's undeniable because it's system. So that's when you may want to use code. You want to use trigger. So use it sparingly. So let's look at views, SQL views. A view in MySQL is a virtual table that consists of a stored query. It does not store data physically, but presents data from one or more tables in a specific format as defined by the query. Views allow you to simplify complex queries, hide the complexity of database schema from users, enhance security by restricting access to certain columns or rows, provide a consistent interface to the underlying table. So you can see what view is. Just as the name sounds, just use it to view table. You know what they call read-only. So a view is a read-only table. It creates a new table. You have the table, the developers have designed their own table. At the end, you create your own view. It's a table. But that table, there's nothing inside it. So the advantage is what we have just seen here. One of the major ones is that it can hide some of your columns. So instead of doing select asterisk, what's the meaning of select asterisk in query? All. So the bad boys may want to select all from your table. But if you are using view, you can restrict the columns you want to be selectable at every given time. So it's a security measure. However, too, you can select things from multiple tables and showcase them. Just like what he said about scanning a medicine. If you scan a drug, you can see the expiry date, you can see the price, the name of the drug, the name of the company, the name of the chemical that that drug is made of. Now, these things may be coming from different tables, but you may not know because there is a view where you are watching it. So the view will just pick the key things you want at a time and show only those ones. Is that? Yes, like the name and price, if that's the only thing that is required, name and price. But if they also want you to see the expiry date, maybe that one will be for them. They don't want you to know. They will look at it. Like, this will expire tomorrow. When are you taking this drug? You say it's today. They'll give it to you like that. But if you know, if you see the expiry date that is tomorrow, you won't buy. You say, okay, this is not expired already. So they can decide the table they want, the column they want you to see, and the one they want to see using view. So how do you create a view? Create a view by saying create view. You put a view name. You now say as. You now write a select statement. So view uses select statement. You don't do update or delete from view. It's just for you to see only. Read only. If you want to perform action, use trigger. Trigger. So you select, you list the columns you want to select. Then put the table name and put the where condition. So look at an example. Create view, employee details. So employee details is the name of the view. When you are creating your own, you can give it any name you like. Also, notice that employee details is employee underscore details. We have mentioned it before. You don't leave space when you are mentioning names. I hope you know that. What are the options you can use? You can use camel case, you can use underscore. Good. So the name of the view is employee details. So create employee details as select ID, name, and salary. These are the only three things that is selected from employees table where status is active. So this will create a view called employee details that shows the employee ID, name, and salary of all active employees. Using views. After creating a view, you can query it just like a regular table. So that query now, like I said, is a table, but there's nothing in that table until you run the query. So even if an attacker attacks that table, they will not see anything, it will be empty. Until when the view is called. Now, view and trigger work differently. Trigger stays in the database. You don't call it. But view is called by the PHP program. So what it means is that if I create a view on my table, I will give on my database, I will give the PHP guy the name of the view. He will call it there, the way he called them. When I say call, I mean you're writing a code to select students. You say select asterisk from students table, is it not? Now, instead of calling students table, you will call the name of the view. And behind the scene, this view may have been accessing data from different tables or may have selected only limited columns. So you don't call the table name, you call the view. If you call the view, it will run, pick all the things that is meant for it and display. So that's what using view is talking about. It said after creating a view, you can query it just like a regular table. Select asterisk from employee details. Employee details is the name of this view. So they are calling this employee details here as if it's a table. Yes, but it's actually a table, but there's nothing in it, it's a view. So this will retrieve the data defined in the employee details view. Advantages of using view. One, simplification. Views can simplify complex queries by encapsulating them into a single view, making it easier for users to work with. So this guy now will just write this single line of code. Select asterisk from employees. Whatever these employee details are, doesn't concern him. You just call employee details. While this may be a complex query that even involves joins and some other complex codes. Advantages of view. We have talked about simplification. Next is data security. Views can restrict access to certain columns or rows of data, providing security by limiting direct access to the underlying tables. So with views, nobody can access your table directly. It is important that you take note of these security matters because crime is no longer on the physical, except kidnapping and few other things. Every other thing now has gone online. That's where the major crimes are happening. And database is the final target. Every destination of attack is data. Every attack comes with data. So anybody that is involving in data must make sure of this security. Because if anything happens, you are the first suspect. If anything happens to your organization, bam, it is you. If you develop a system for people, you hosted it, they are using it, you are no longer using it. If anything happens, they will still call you. So that security is something you don't play with. That's why our lecture is going this way, so that you take note of all the security measures you mentioned. Make sure you implement all of them. Don't joke with any of them because there is war out there. So we're talking about the advantage of view. One is security, the other one is consistency. Views provide a consistent interface to data, even if the underlying table structure changes. So it doesn't matter whether they altered the table, the view remains constant. Anytime you call it, it will give you what is there. Then reusability. So views allow you to reuse the SQL queries and ensure that the same logic is applied consistently across the database. So you can call the view anytime you want to call it because it's stored in the database. Views with joins. Views can include join operations to combine data from multiple tables. This is useful when you frequently need to work with combined data. You guys have done join now. Did you do join in MySQL in PHP? Hello? But you told me you've done join this morning now. When you say you were able to access multiple tables, is it not join? Some people say yes, some people say no. But at least you have heard of join. Uh-huh. So now that join, you can see that it's complex when you're writing it with PHP. But you can use view, write it on view, and then let the PHP guy just call the view name. The whole complexity is hidden. Example, create view department employee details. That's the name of the view. As select e.employee ID, e.name, e.salary, d.department name from employees, e. So you might be wondering what is e? E represents employee table. Join department, D. That means D represents department table. On E.department ID equal to D.department ID. So you can see how complex join code is. But if you manage to write it on view, you just share it with PHP guy and he calls the name without knowing the code you have written behind it. So this view combines employee data with department information by joining the employees and department table. So you can join as many tables as you want. Let's look at indexed views or what we call materialized views. MySQL does not support materialized views natively, but if you are using SQL Server, it can handle it. But MySQL does not support it. A materialized view is a view whose result set is stored physically for performance. In MySQL, you can simulate this behavior by creating a table to store the result of a query and updating it periodically. Like we said before, this index is actually a table, but anytime you access that table, there's nothing in it. It's always empty until when you run the query code, it will populate it just for view. Once you close that window, the table is empty again. It doesn't stop. But what we call materialized query is the one that has the ability to store what you viewed. Are you following? Normally, view does not store data, it displays data. So when you call up a view, you will see results. But when you close that window, the result is gone. It's a view only stuff. But materialized query views can store that information. But MySQL doesn't support it. So if you want the one that will store what was viewed, you have to create a live table and save it there by yourself. So how do you simulate materialized view? You create a table to store the data. So this one is not a view now, it's a real table. You create it. So you pick what was viewed and stored it there. Populate it with the result of the query. Then refresh the table by running the query again. Create table employees summary as select department, count everything as employee count, average salary as average salary from employees group by department. What is this code doing? This is a view, but the guy wants to save what was viewed. He didn't just want to collapse the table again. He wants to store it somewhere because you can't store it in view. So that's what this code is doing. So this employee summary table acts like a materialized view by storing the aggregated data, which can be updated by running an update or insert into query periodically. So look at performance considerations. When you are using view, there are things you need to know. One, views do not store data. I've mentioned it before. It's a collapsible table. Once you are done viewing, it collapses. Since views only store the query and not the data, the performance of queries using views depends on the complexity of the underlying query. So what views store is the commands, not the data. Optimization. MySQL will optimize the underlying query when the view is used, but it may not be as efficient as directly querying the table if the view is complex. You cannot directly index a view. What we mean by that is that you don't store the data that you have viewed for you to reuse it again. No. But you can index the underlying table to improve performance when querying through it. So what you can do is to fetch that data and store it somewhere else so that you can use it. Best practices for views. Keep views simple. Avoid creating overly complex views with many joins and subqueries. Complex views may reduce performance and make maintenance harder. Remember that the database is not meant to carry code. It is meant to carry data. By the time you start writing code on your database, you are adding extra load to that database. Both the memory of the system, the speed of the processor, and the bandwidth of the network all are affected. So these codes now that they are writing on the database should be minimal. You don't replace it with PHP. Let all the codes be written in PHP. You now use these ones when it is important. When there is need for you to use them, you use them. But use them minimally, only where necessary. Don't try to depend all your database codes on stored procedure because it's going to affect the performance of the database. Except if this database is stored in a cloud where you are sure that there is unlimited resources. In the cloud, there is no amount of RAM you want that you not have. There is no bandwidth you need that you not have. There is no storage space you want that you not have. So if you're writing this code there, it's okay. But on a physical system like this, it's usually an issue. So you watch out for it. Use views for security. So if your aim is for security of your database, you see that it will naturally be minimal because you won't write all the codes. You only write the ones that protect your data, not just to execute the application, but to protect your data. That will make it minimal. So use views for security. Restrict access to sensitive data by creating views that expose only necessary columns. So columns like that, password, you hide it. Phone number, you hide it. Account number, you hide it. VPN, you hide it. Provided they are not needed. Avoid using views for write operations. Although updatable views exist, they are not always efficient for write operations. Use views mainly for read operations. What they mean here is that the 4 SQL statements: select, insert, update, delete. The one for view is select. Don't try to use it to do insert or update or delete. Regularly review your definitions. As the database evolves, periodically check if views are still relevant and optimized for current needs. Remember that view is just a code. If they have modified a table, maybe there is a column before called matric number, and in your code, in your query code, you have said select matric number, and all of a sudden the school said we are not using matric number, we are using reg number. So they have changed the column there to reg number. If your query is still calling matric number, it will not see matric number. So anybody viewing that assessing that view, we have error. So don't think that because you have written the code, you now go and relax. Always check that there are no changes on the table. You can use triggers to check that one. So you create a trigger. Anytime there is alteration on the table, you get notification so that you now know how you handle the rest of the work. Conclusion. Views are an essential feature in MySQL for simplifying complex queries, improving security, and providing a consistent interface to the underlying table or data. By hiding complex SQL logic behind views, users can interact with data more easily and safely. However, it's important to keep performance and maintainability in mind when designing and using views. So these are some review questions these review questions are part of the document that have been uploaded on the learning management system. So when you go there, you will see these questions and try to answer them. It's an assignment, so you answer it and submit. Okay, so let's do the practical. Let's see some of these things in practice. Load your XAMPP. Load your XAMPP. So you go to phpMyAdmin. So inside here, you can select a database that you want to query. We are using student DB. In student DB, we have a table we call lecturer. And we have inserted some things in it. Are we here? Just open a table, even if it's not this one. Open a table in your this thing. Then you go to triggers. See triggers here. Are we there? Then you click on create new trigger. So on this new trigger box, it will ask you to select the table name. Because we are working on lecturer, lecturer name is already here as a table. But if that's not the table you want, you can select another table. Then you can give the trigger a name. Of course, the trigger must have name, otherwise it will not work. Then you select the time. Is it before or after? When do you want the trigger to execute? Then you choose the action or the event. Is it when insert or when update or when delete? Then you write the code. So everything you want to do is inside this table. Okay, let's call it before delete, before underscore delete underscore lecture. You can call any name you like. Before delete underscore lecture. You can also use small letter, it mustn't be capital letter. So what do you want to happen before deleting the lecture? You can write the code here. So let's take one of these codes that are here and execute it. Hmm? Yes. This after now is before that we are changing it to. So what we are saying is for each row that you delete, insert into a table called deleted employees. So we are going to create this deleted. So our case now will be deleted lecturers. Deleted lecturer. So we have lecturer ID, the name, and the delete time. So we have old dot ID old.name and now. Yeah, before delete lecturer. No, this is the name of a table. Insert into a new table. I want it to insert whatever is deleted in another table. Are you done? You guys are done, right? Okay. So you, but remember that we've not created this table. This delete lecturer is the name of a table. We have not created it. So we go and create it so that when the query executes, it will store there. So you click on go. Actually, it's giving us this error, like I said, because we've not created that table. That table does not exist, so the query cannot execute there. So let's create the table. We'll come back to it. You can please copy your code and keep so that you don't start doing it again, so that we don't waste time. You see what I did now? I opened the TST file. This is a TST file. That's part. Copy the code and paste it here. Copy the code and paste it there so that it will be easy for you to just copy and paste it back. I'm waiting for you. Are you done? So let's create the table. So inside this student DB, that's where we are. You click on new so that you create a table. The normal way we create tables. The name of the table is deleted lecturer. Then the number of columns, the first one is ID, which is the primary key. Then we have the one we call lecturer ID, capital letter L, and small letter ID. Then we have name, all in small letter. So this lecturer ID will be small letter. Everything in small letter. Then deleted time. So these are the things that we have. Deleted time is time, or what we call timestamp. The name is varchar and the ID is integer. So let's make this one 60. Then this is AI. The ID is AI. This ID. So we have ID, lecturer ID, name, delete time. Yes, ID is the primary key. You've created the tables, man. So you click save. So we go back to triggers. New trigger before lecture. Hmm? Lecturer now, you're working on lecture. There is something I didn't check. The name in this lecturer table. Wait. Okay, name, phone, and email. Okay, right. Sir? Okay, okay, okay. Sir? This one. Deleted lecturer. Lecturer ID, name, delete time. O.id, O.name. Now. Yes, delete before. Are you looking at my code? Yeah, I'm done. So look at my own code. Check now. Check why there. Is it if you see error, you run. You don't have lecturer. Change that table. It's a drop down. Why won't you have lecturer? This is a table. I'm seeing something here. When some of you guys will run your phone, when it has on, you just delete it. What do you think that error report is? That error report is what is telling you what is wrong. Read it. Read that error report so you see what is wrong. So run it. Because I need to start. What I need to do. No. Yes. Yes, and he said something. Yes, because those ones are not. Why do I say it's why do I say because we are putting system, what are saying what the system. So I feel what we are doing. We are doing this thing. That's what we are doing. It must be done benefits. So who is having issues? So there is something that is something to change the latter. So delete delete something. When you delete it, you see what will happen to the other table. It will automatically report there that you have deleted this thing. What I mean is open this lecturer table. Open lecturer table. When you open it, delete something there. I want to delete Prof. Tunde. His ID is 2. So I'll delete him. I've deleted Prof. Tunde. Now, if I go to deleted lecturer, I will see him there. Prof. Tunde number 2 has been deleted. Open your lecturer table, delete something there. Now, go to deleted lecturer, you see that thing. Have you heard of the site admin before? Yes. And do you wonder how they design it? You can also write another trigger. When you delete from delete lecturer, that you should go back and insert it back in the main lecture.
Okay, like when you restore.
Those things are, if it is necessary, you don't have to overload your database. Stop this. Just go ahead. The trigger is now deleted. Check whether what deleted is Vivian. So anytime they do something, they left it. If it's deleted, not deleted. So is that you correct your correct Okay, so that is it. That is how to have a stored procedure on your database. So this deletion, whether they deleted it from PHP or you delete it directly, it will save a copy for you. You can as well write any type of code you want using before or after, depending on how you want the code to be. It will perform. Yes.
Now, how do you know
Okay. So you can write a code that will check the privilege of the person. There was a class that we had earlier. Let me see if I've seen that class. Forgotten the name of. But I know we did it here when we talk about privilege.
yes? That's
Uh-huh. Don't know whether it's SQL injection. Where do we have that class?
yes, that's it.
Mhm. We talked about users, creating users and user privilege. There's a code you will write, it will tell you the user that is accessing the system. I don't think it's here, but you can find it. You can go online and check it. So you write that kind of code, it will tell you the user. So you store it as well.
So that it's storing
It's, yes, the person that is accessing it. Yes. All right, so that's the class for today. Are you guys saying today is the last class? Hmm. Actually, the next class I wanted to teach you guys is this join. But since you guys have learned it, join. Okay, on Wednesday or next week. Tuesday, sorry. On Tuesday or on Saturday, if there will be class on Saturday, we'll practice it. Then Tuesday, we'll look at it theoretically. So it's also an important aspect of SQL. Tuesday and Saturday. Um, yes, if they will open here, I can come. Otherwise, I will give you a PowerPoint that you can use, or I create a video that you can watch any of them. Trigger. Mm. Yes, I saw one. I saw somebody accessing it already. It's not in form of PowerPoint. It's in form of PDF. But I can also upload it. Maybe I'll upload this one. View. View. You write view as SQL. You write it here. Where they say select from. Click on SQL. You write the view code here. So what is schema? Have you heard of the word schema before? Schema, schema. What is schema? Something like this. So when they ask you about database schema, I'm saying this because you are going to write exam. Not only because you are going to write exam. If you have done anything on database, if you are interacting with other people or anybody about database, you'll be hearing the word schema. So schema is the structure of your database. If they ask you table schema, that's the structure of your table. If they ask you schema of your database, that's the structure of your database. Like for this table now, this is the schema of the table. If it's a database, like if I click on student database, the schema of this database includes the tables, the views, the triggers, all the stored procedures if the table has them. But if the table doesn't have them, I mean the database, if the database doesn't have any of these things, fine. So only the table becomes the schema. Then if they're asking you about the schema of a table, that means they're asking you about the structure of the table, the columns of that table, the constraints. Constraints there includes primary key, auto increment, required, that is unique, and null, not null, all those names. That's what make up the schema of a table. So you should know what schema is. I just want to mention it to you. That schema is the structure. It's another name for structure or content, structure and content of that data item. If it is a database, fine. All the tables, all the views, all the stored procedures, triggers in that database. If it is a table, then they're talking about the columns and the structure of those columns, like the data type, the length, um, the constraints, like null, not null, unique, auto increment, and all of them. So that is what schema is. All right, so we meet again next week. Before then, try to look up SQL, CSQL. Yes, this one that's saying that the class is ending is. I wanted to show you how to do relationship. How tables relate. It's Workbench that we used to do that. On your own, you can install it. Maybe I will just prepare a PowerPoint and show it. It's very easy. Just click here, click here, click here. It will draw the map for you. No, it's from Workbench. I want to check if I have Workbench.
I saw something like that.
I have Workbench. So you have
I
something.
saw something like that.
Where did you see it? I don't have Workbench, okay? That one is online. It's opening as a file online. Look for it. It's only on Workbench that you can do it.
Yes.
Okay.
So it's on that button.
On that one.
Yes. Clicked on designer. Then clicked on create relationship.
Okay, great
You
questions.
now created this table.
Fine. You can drag this and bring them close.
Okay.
Mm.
Yes. You create relationship. On the left hand side, you see some. Yes, you see some. There's some icons. will create, once you click it will create
So you can see the relationship. Yeah. Okay, that's great.
it's asking you to do something. It said select the reference key. But this thing depends on what you put when you're creating your text. What primary keys, those things. That's what we determine.
But see how Workbench is. This is a complete software. So you can see the relationship. This one have how many tables? 1, 2, 3, 4, 5, 6, 7, 8, 9,
And it has those keys.
10, 11, 12. Yes, and it have those
These
keys.
keys now is what I'm still trying to understand.
Okay. So Workbench is meant for this. It's designed for creating this relationship. So if you are developing a software, you just create the links and then save it. New model. So in your model, you add a table. You can add model or view. You can add model or view. So you add table. So you create the table, give the table a name, then start adding columns. ID. You choose the constraint of the table. This is primary key, not null, unique, and so on. Auto increment, name. So when you are done creating all the tables, you go to create diagram or relationship.
So do you say, is this what we share with the developer
Yes,
or just design?
those designs, that relationship. No, not with the developer. It's part of the, well, if you say developer, it's part of the documentation. You put it in the document so that a developer can look at it and know how the tables are related. Yes, you share the details. This is the work I did already. The one I just shared with you. It's a work we did for aviation. Uh, Staff performance management system. Ministry of Aviation. So if you get Workbench, maybe I'll share a PowerPoint with you how to do it if you have Workbench. We'll also see if they can extend the class, maybe for another month or week. So that's the end of the class for today. So read up, learn how to use ChatGPT or any of the AIs to help you generate code. You clean it up and use it.